Yeah, very good evening. Good afternoon. Yeah, good evening, good afternoon. So have you practiced some of your sessions for NumPy and pandas as well? Have you did those? Okay, so let's start. Hello. 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 Can you hear me well? You can come and interact. You can write here. Okay, so I'm asking. Okay, so have you practiced of your session for NumPy and little bit of the pandas as well? Are you practicing the Python as well from practice repository? Python practice repositories also? Are you doing from there? Okay. Thank you. Thank you for responses. Very good. Okay. Thank you. Thank you. So let's go. So which topic I had just started? Can you tell me? Which library I just started last time? What are the two major data science library I told you yet? Good evening. Good evening. Which two libraries I had told you yet? Which two libraries I'm covering now? Right. Thank you. So library I had earlier covered. That one is a NumPy. And now we are talking about the pandas library. Of course, good evening. So we are just doing NumPy and pandas here. So I just started with the pandas library last time, and we had told that what is the pandas? Pandas is a very important data science library. Okay, pandas library is used for the data analysis purpose. Pandas will facilitate us to work on different types of data types. We can work with integer, float, string, Boolean data. Pandas has a lot of internal functionalities for mathematical expressions. Also, we can work with certain aggregate functions. So tell me, like in pandas, we are having which two data structures? I had told you there are certain two data structures. Thank you. So I had told you what are the two data structures. Can you tell me? Yes, I had told you about the NumPy. But recently I started with the pandas. Can you tell me what are the two? Which are which are the two data structures I had told you about the pandas? Very good. Good. Yes. So I had told you about the two data structures of pandas, and that one is series and data frame. Exactly correct. So when I'm talking about the series is one vector data structure or one vector of one dimension data structure. Okay. And in data frame, yeah, thank you for responses. And in data frame, we can work with two vector data. We can work with two dimension data where I can take X and Y. X and Y means I can take the rows and columns. So it means I can build up the table-like structure in case of two-dimensional data. Okay, two vector is two-dimensional data. I have shown you. Okay, just tell me when I'm going to work with pandas, which library I need to call and how I will be calling that library. Can you tell me? I want to see that you are remembering those things or not. If I want to call the pandas library in my Jupyter notebook, which command should I give it here? Good, good. Right. So the command which I would be using, import pandas. See, directly also I can work with the pandas, but it is better to work with the alias name, so as PD. And now I can use this PD and I will be working a lot of functionalities associated into the PD, pandas here. Is it okay? Okay, thank you. Good. So you are remembering all these things. Very good. Everybody should tell me. Only few students are answering. You should respond me here, okay? Because if you respond, of course, I can get that, okay, you are involved, you are interested, you are feeling confident of writing the library. Got the point here? So you tell me how many of you have practiced pandas library series element, which I had told you last time. I had told you just series element. Can you tell me how many of you have practiced? You can come here. Okay, raise hand, that's all. You can just raise hand. I will be getting that you people had practiced it on your own. Okay, that's good. Fine, thank you. I got you that all of you have practiced. Very nice. Okay, so we were working about the series. I had already worked onto the series. Series is a one-dimensional data. I had already worked. Now let's see, suppose I want to work with the data frame. I just started with the data frame. I had shown you how to write the commands. So import data frame, I did it. Import pandas as PD. Okay, and from here, PD dot data frame, I need to write it here. Okay, inside data frame, I can give certain values. So the point is here now that data frame gives us labels of rows and columns here. Okay. So remember, we are having a capital D and capital F as a data frame. Never write it as small d or small f, please. You have to take care. So just a moment, wait here. Students, those who are joining it late, please come on time. Already 10 minutes are there, so please come on time. Okay. Just wait here. Just wait for a minute. Okay, so I told you about the data frame that whenever we are working with a pandas data frame, so data frames are two-dimensional data structure where the data could be aligned in tabular fashion in rows and columns. The features of the data frame are they are potentially columns are of different types, means we can work with the integer, float, boolean, string values there. Their size are mutable. It means we can grow up with the number of columns as well as number of rows also. I can extend it here. We are having labeled axes, rows and columns. So it means here we can work with the name of the axis, means here we can work with names of axis as a rows and column. Means here I can give the name of the columns as well as name of the rows also. Rows means here they are indexed basically. We can perform the arithmetic operation of rows and columns here. So I had shown you a number of commands also last time. Like here, this one is the data list I had provided. I am just providing this data into the means inside the data frame. So here my data frame is created. Already I told all this command. We did it all this command. Just I'm making a small revision here. That's all. So here, this one is I created a list into the list. So whenever I'm just passing this list inside the list of data frame. So here I'm having this kind of structure. So actually, when I'm writing here, so you can see here, this one is a column number 1 and column number 2, row number 1, row number 2, and row number 3 as well. Okay. So if I want to give the name of this column number 1 and column number 2, so there inside the data frame, there are certain parameters which needs to be settled down. So here I can give a data. Inside the data, I can just provide the list inside the list. Second, here I can just provide the columns as well. So when I'm providing the columns as well, so column is one of the parameter where I can assign the column names, header names. I can call it a column names or header names. That also I can assign it. So if by default, these axes, X and Y axis, if I want to put this axis as a column 1 and column 2 with certain name and age, so they inside column parameters of data frame, I can just write here name and age. So name and age will be started reflecting here as a column number 1 and column number 2. Okay. Now inside data frame, we are having the data type also. So if I, by default, what happens, the data type it is taking as an integer. So name age is coming as an integer. Means any integer value, whichever I am passing, by default, it is an integer. So, but if I want to change any of the integer into the float, so here I can settle down the third parameter, data type, D type is equal to float. So here all the values coming into the integral form, they will be started giving its visibility in float mode here. We did this one also, if you remember, I had just created a dictionary. This dictionary I had created. So here inside the dictionary, you can see we are having a name and age. So name and age are what? Name and age are key and these are values. So here, if I want to represent name and age as a key and value, so here into the data frame, I can just represent it as in this way. So what will happen? Name will come here and age will come here. So here, Tom, whatever name is there, so their name and age is there. You can see here, name and age is there. Got the points? Remember, students, see, actually, now here, keys are always represented as header. Keys are always represented as header. Remember this point. Okay, up to here, everything is clear about the data frame. Just you can raise hand. Everything is clear about the data frame. You can just raise hand. Up to here, you are confident now? You can just work with the data frame. Okay, good. Thank you. Thank you. Thank you. So, thank you. Okay, now let's move ahead. Let's see this example, how the values of the NaN are represented. Can you tell me, do you have any idea of NaN? I told you earlier. What do you understand by NaN? N-A-N. Just you can hint me that, ma'am, NaN represent this. You can give here. Come into the portal, query portal. You can just tell me, ma'am, just you can give me that NaN represent this. So I can understand. Missing data, missing value. Okay. Okay, so this one is a, just wait here. Okay, thank you. So this one is a missing data or missing values. Very good. So it means I do not have a data with me. So the data absence is there. The data absence is there. Okay. So let's see here how missing values into the data. Good, good, good. Good answers. Okay. So here you can see. Okay. So now see this case very carefully. Suppose here I want to build up a data frame. So here I want to represent a missing data. I'm giving here a dictionary. I'm just creating a list, and inside list I'm just providing a dictionary. It means I'm providing a dictionary inside a list. So inside the dictionary we are having a key value pair. So with the key value pair you can see, suppose you see this case here, this one is the first dictionary and this one is the second dictionary. First dictionary and second dictionary. So here you can see, if you check out the case here, A and B, these are two keys inside the dictionary, this first dictionary. So let me take out the keys here, A and B. These are the two dictionary keys. And now you come to the second dictionary. This is the second dictionary, and here you are having A, B, and C as a keys. Okay, so inside this dictionary, we are having A, B, and C. A, B, and C. Okay. Now let me take out the values from here, because here we are having inside of this is the first dictionary. So what are the values here? 1 and 2. 1, 2. So A is having a value of 1. B is having a value of 2. Now come to the second dictionary. A is having a value of 5. B is having a value of 10. C is having a value of 20 in second dictionary. So the point is, this first dictionary, this is a first dictionary, this does not represent any value for C because there is no data for C. So what Pandas will do, Pandas data frame will be automatically filling up the values here inside the C with NaN. The point is here, the system will automatically fill up the values with NaN. Okay, so it means if there are columns and inside those columns we do not have any values, so those values will be filled up with the NaN values. So you can see here, when I'm taking this data inside the data frame, so the values which are coming here, so automatically the values which is taking here for A, it is having 1 value. For B, it is having 2 value. But there is no C, so NaN value will be automatically. In second dictionary, in A, the value is 5, so Y 5 is present. In B, 10 is present, and in C, 20 is present. So in this way, the data frame will be filling up the value. So remember, the NaN values represent missing data. Wherever we do not have any kind of data, we cannot provide it as a 0, we cannot provide it as an null, means we do not have any information. So that is represented as a numpy.nan automatically. Okay, I had also written here D type is equal to float. So all the data which is coming into the integer, they are represented with the float data. Even you won't write it, so you can see that will be coming into the integer. So this is the case of NaN representation. Now, when you see here, the index number 1 and index number 2. Here, if you want to give names to these rows, how can you give? You can just write here the same dictionary. I'm passing it here, and here when I'm passing it, I'm also recommending index parameter. Index means I want to give the new name to the rows. So here, first and second, I'm just giving the name to the rows. So by default, the rows are represented as a 0 and 1. And these columns are represented as a 0, 1, and 2 with the index numbers. But here, if you want to give a labeling to the rows, you can just give it with the index parameter in this way. Okay. Now, second here, inside this case here, suppose, see, I'm having a column A, B, okay. in first dictionary. So what are the values? 1 and 2. So 1 and 2 values are there. Okay. Let's check it out, the second dictionary. The second dictionary is also having keys A, B, and C. C is there. So what are the values in A and B? That one is a 5 and 10. And inside C, 20 is there. So here, nothing is there. Automatically, none will be filled up. It's okay. Fine here. So, okay. So here now, just wait here. Okay. So here you can see if I want to see inside data frame. Right now I'm having A, B, C as a column. 3 columns I'm having. Okay. Inside data frame, currently I'm having a 3 columns. Fine. Now, if I do not want to see all 3 columns, I want to see only 2 columns A and B. It means I want to specify A and B. That's all done. I do not want to see C. No. So how can I select a particular column? So when I'm writing here pandas to data frame, so here I'm passing this entire data frame. I'm giving the name to the rows also as a first and second. So whichever column I want to see, I can just give the names here inside the column parameter. It means I can give a selective names of the column which I want to give inside the data frame here. So I can just show me A and B. So it is going to show me only A and B column. That's done. Okay, so this is the case because we are having the values of A and B. So it is just representing you. But the second one here, see here, this one. You think, suppose I'm having only how many columns? A, B, and C. So A, B, and C, only 3 columns I'm having. So what happens? You can think, if I say, show me A and B, so of course it will be showing me A and B. If I say, show me B and C, it will be showing you B and C only. But if I want to see B1, I'm saying just show me B1. I know that there is no B1. There's nothing B1 here. So if I want to see B1 here, so because there is no B1 column, automatically it will start showing the B1 column with NAND data. Okay. So here I'm having with everything with missing NAND data. Remember, students, if any column which is not present into the data frame and we are giving the name, so automatically NAND values will be there. You can see here NAND values are here. See here. NAND values. Here it is just representing missing data. So it means if this B1 is not there, so NAND values will be automatically there. So remember those things that inside data frame, whenever my columns are not present, automatically though that column, the column which is not present, and I want to see that column, automatically that column will be displayed with an NAND value. It means it shows that there is no column with a B1. But here A and B are the present column which are having the corresponding values. Up to here now it is okay. Is it okay? You can just raise hand, that's all. Okay. So let's move ahead now. Let's move ahead. Okay, fine. Just wait. Okay. So this is a one basic starting of the pandas is there. Now let's say how to go ahead with the pandas indexing and slicing. The way we did the indexing and slicing into the list, if you remember during the Python, similarly we can do the indexing and slicing in pandas as well. So let's see how we can do that. You think it suppose inside pandas data frame. Suppose this is the data frame. I'm having certain columns. Let me take certain columns here. So what happens? Suppose column number 1, column number 2, column number 3, 4, and 5. And here we are having certain rows as well. Row number 1, 2, 3, row 3, row 4, row 5, and goes on. So the point is here, by default, these columns and rows are having indexings also. Indexings, default indexes they are having. Now suppose here I want to fetch out, I want to make a indexings of these columns or rows in case of pandas. So how can I do that? There are basic two operations inside the pandas data frame. Okay, inside the pandas data frame for slicing and indexing, we are having two operations that can be done through lock-based operation and iLock-based operation. Lock-based operation is a location-based or label-based operation. iLock operations are index location-based operations. Lock operations are basically, we have to give the label name. Every time I have to depend on to the label name. Think it out that I'm having a values inside it. A lot of values. It could be any value, any type of value. The objective is to capture the particular index values, index column entirely. So if I want to use a lock, suppose here I say, I want to see this particular entire column. Okay, so what is the basic functionality I need to write? So here now there is a particular syntax of writing lock. PD, okay, pandas.lock operation. Pandas.lock operation, inside it, I have to give two parameters. What are those? I have to give the parameters related with rows and the parameters related with columns, rows and columns. Okay. So now, here now in rows, I have to give the starting index and ending index. Means here now in rows, this is a range of rows I'm giving. Range of rows means here up to how many rows I have to take. So I have to give the start index and end index. I have to give start index of rows. I have to give end index of rows. And in columns also, I have to give a start index and the end index. Start, end, start, end, start, end. I have to give every time. So here now, suppose I'm framing a pd.log operation. So I want to capture this particular column here, this particular column that I want to capture. So how can I do that? For that, simply I'll write it here, pd.log operation. Now I have to give two parameters here. Okay. So that one is, I can just give, suppose here you think I'm this column number 1, column number 2, I'm just giving a name here, A, B, C, D, E. I just provide the labeled name also, A, B, C, D, E. So what I can do, I can just write it as pd.log. So here I have to, into the first parameter, I have to give the rows, and in second parameter, I have to give the columns. So here I will say, show me all the rows. This is a range function also. Range means from starting to end automatically. So I'm saying just show me entire rows. So here I'm giving blank rows. I'm giving show me entire rows. And which column I want to see? Column number A I want to see. So I will write here, show me column number A. I'm saying show me column number A. So it will be showing the entire column with all rows of A. Suppose here I want to give another. I want to give here, I want to see C column here. This one, entire C, entire column. So how my command will go? So I will just write here pd.log. Log means label based operation. And I need to provide the two parameters. So I will give here blank, means here I have to provide start and end. So because I'm taking an entire row, so no need to provide start and end. It will be automatically taken as a complete number of rows. And in the column, I will just write show me C column. Okay. Suppose here I want to take here C and D column. Let's say C and D column. So what I will do it here, I will just write an operation pd.log. Here I will say, show me all the rows, show me C and D column. Okay. So in this way, I can just take the data of C and D column. So the point is that in this way, I can do the indexing. But there is one point here, indexing or slicing. So, but there is one point here inside the log operation that every time I need to remember here these names of the labels A, B, C, D, E. So name of the labels I have to provide. So that's why the name of the log operation is label-based operation. Label-based operation. Now there is another way, another easy way. Instead of making the label-based operation, I can go ahead with ilog operation also. In case of ilog operation, what I need to do, I do not remember the A, B, C, D names of the label. I will be interacting with index location. So let me show you how we can do it. How we can do that. That is, just wait here. Wait, student, just wait here. Let me. Just wait. So, like I told you, for slicing or indexing, there are two operations like log and ilog. So let me use an ilog operation. This is much preferable operation. As the name suggests, index location. I stands for index. It will be allow you to take the index location. Index location means, suppose you think I'm having this column. I'm having this table. I'm having this table. Okay, so you can see here, like some column names I'm just providing. Indexing and slicing are very important concept in Pandas data frame here. Whenever we need to find out a particular column or the rows, we do use indexing and slicing operations. Okay, so here I'm taking here names. Okay, so here I'm giving the indexing. Basically by default indexings are 0, 1, 2, 3, 4 and goes on, and the indexing of the rows are also present default. Even students who are not giving, in this way the indexing will be there. Now you think it that there are certain values provided inside this, certain any value, it could be any value, but the data are provided inside this column, it could be any, it does not matter. In entire tables the data are present here. Now let's go ahead and do the index location. Let's do the slicing and indexing with the help of ilog operation, ilog. So how I can proceed with the ilog here? This is very easy inside the pandas with the ilog operation. For this now, you think, suppose I want to capture this entire column. Indexing I want to do with this entire column. So what operation I need to write it here? I will be writing here pd.ilog. Ilog means index location, and here I need to give two parameters. The first parameter indicates the number of rows and the second parameter indicates the columns. Inside the number of rows, I have to give the range. This is the range, start index, end index. This is a general formula. And in columns also, I have to provide start index of columns and end index of columns. Okay. Now here, if I want to see this complete zero, I want to capture, the simply I will write it here, pd.ilog, and in ilog, I will be giving show me entire rows. So there is no need to give any start, any end. Automatically, it will be taking from 0 to end. Okay. And I need to give a column only. Which column it is asking? It is asking 0. So I will simply write here, give me 0. 0 means show me 0th column. So here it will be giving you entire 0 column details. Entire details indexing it will be giving you. Think out operation. Suppose I want to take out operation to see this entire 2th number column here, this 2th index number column here. So I will be writing here pd.ilog. Here I will be giving show me entire rows starting and end, and here show me the 2th number of column. So this 2th number of index will be there. Think it, suppose I want to give here operation for this 4th number entirely. What I'll write it here, simply I will be writing here pd.ilog show me entire rows, all the rows, and the column number 4. So here it will be giving the details of entire 4th column. Okay, this is one case. Now what I can do, suppose I want to be selective with rows also. I do not want to see the entire rows. I want to be selective with the rows. Think it, I want to see the data of this 0th column up to here. See, up to here I want to see 0 to 4 only. See, up to here, be careful. 0 to 4 only, 0 to 4. 0 to 4, not entire. 0 to 4 means that, now see, how to cut this data. How to select a slice of the data, 0 to 4 only. So here now, where I'm representing this rows now, so here I need to make a cut. Now remember one thing, that I have shown you that in rows, I have to write here start index and end index. So start index, if I want to write the data with 0 to 4, So the starting index will be 0. I'm saying start the index number from 0 in rows. Now let's come to the end index. So students, n index now, I have to take n plus 1, means here the index up to which I want to make the slice. So I need to take the index with plus 1. Okay, because what will happen? My index here will be not reaching up to the n values. It is reaching to the n minus 1 value. So what I'll do, suppose I want to capture 0 to 4. So I will write here, just show me the data up to 0 to 5 here. Okay, so when I'm writing here 0 to 5, okay, so here now, I need to work here, that kindly write here 0 to 5. So what will happen? All the data from 0, 1, 2, 3, 4 will be captured. It will be more clear when actually I am doing it on the Jupyter notebook. Okay. So here, if I write here, start the data in rows with 0 to 5. So it will be starting calculating the rows from 0 to 5. It means 0, 1, 2, 3, 4. Last will not be taken. N minus 1 values will be taken here. And here I'm saying, just show me the columns here. Columns up to 0. So here it will be giving me the data from 0 to 4 only. Suppose here I need the data from here. See, up to this data I need. It means I want to see the data from 2 to 5. Starting the values from 2 to 5 only. So how can I get it? So 2 to 5 basically I can get it that give me the rows starting from 2 and the end data, the end rows will be 5. So but you cannot give it 5, just give it a 6. Because the range will be started counting of rows from 2. Suppose this is a starting 2, 3, 4, 5. So 2, 3, 4, 5. That will be started giving in 2th number column here. Got the point here? So now you can see here, suppose I want to capture the data of, it's better, I'll be coming to the Jupyter and there you will be getting more idea. But here, at least you are getting that how to write it, okay? Here I'm going to write it. Wait. So let me make certain rows and columns. So here I'm going to make the rows and column with random numbers. It could be any number, does not matter, but I need the format of table in a table-like format. So here I'm making a table-like format for making the rows and columns. So what I'm doing, I'm using a NumPy random function to generate the random data. It will be generating any data. Later on, we will be performing the operation of lock and iLock. So what I'm doing here, I'm taking the data here. Both of the data I needed. Both of the data I needed. Then I need a data to generate the random number. So here I'm generating a data with random numbers here. Okay, so I'm right. This one is a syntax for generating the random data. I'm just taking it here, np.random.random function, where 8 rows and 4 columns I generated. 8 rows, 4 columns, and here the column names are A, B, C, D. Now suppose here I want to select this one, this data A. So here I will be writing, this is a data frame I had created. pd.data frame means I just created the data frame here. So here now I need to call this data df. inside the DF, if I want to write here lock operation, so here I would be giving the rows and columns. So here I'm just giving comma. So here I'm just giving the rows data. So what will happen? Automatically it will be taking start index and end index. And here I need to give A. A means I'm saying, give me the rows and column number A data only. So you can see here, it is just giving me only this data, only this column it is going to give me. Only this column it is going to give me. Because in df.lock operation, what I had given, I have simply given here that inside this data frame here, dot lock operation here, just to give me all the rows. So what will happen, student? Automatically start index will be starting from 0 and end index will be automatically to n minus 1. And here also I am giving A. So here it is going to give me, take all the rows and take the column number A. So here it is giving me the column number A. Suppose here I want to capture column number C. C number I want to capture. This C number I want to capture. So here what I do, I will be writing here df.ilock here, which is column number C. I want to capture here column number C. So I can capture it here. It is a lock operation. Sorry, it is a lock operation. So column number C, it's being captured. This column which is coming here now. So C number it is. This one is a C number. C, just wait. C, wait, and C is there. You can see here. C is there. This C is there. Got the point here? So column number C we had captured here. Okay. Now suppose here I want to capture C and D here. C and D I want to capture. So df dot lock operation, lock. I want to see all the rows and I want to capture here C and D. So here again I have to give the data in this way. But actually, so here I'm getting the columns of C and D, C, D, above C, D. I'm just getting. The point is here that, but here I need to remember what are the names of column A, B, C, D, E, F, G, H, and in this way I have to remember. Why not to come to an easy way here that where I can just work with the indexes here. Okay, how can I do that with the indexes here? Okay, now let's do the work with simplification where I can do the data work with the indexes so that there is no need to remember the indexes. So what I can do in that case here, I can generate a random number. So what I'm doing, let me use a ilock operation. So same or any other random number you can be generated. So here I'm just using numpy.random function I'm using where I'm generating 8 rows, 4 column. And now here 8 rows, how many? 8 rows means 0 to 7 rows and 0 to 3 means column here I'm having. So here I need the df.ilock operation. So let's see how we can go ahead with the ilock operation, because what are the benefits of the ilock operation is we are having the indexings I'm having. Automatically the things are indexed here. So here na 0, 1, 2, 3, in this way it is there. And here also you can see 0, 1, 2, 3, 4, 5, 6, all these things are here. So here the operations are much more easy, ilock operation. So what I can do, suppose here, I'm just taking this df. So df.ilock operation I'm going to use is I means index location. This 0, 1, 2 I can give it. Same operation I need to take it here. I have to give the rows range and also I have to give the column ranges also. So rows range and the column ranges I have to give. Start, end, start, end. In this way, I need to give it. Okay, so let's go ahead. So what I'll do, suppose I need this one, this data I want to index. So what I'll do, I will just write simple operation df.ilog, and here I would be giving it rows, all the rows it is. So I will be just giving, that's all, done. So all the rows will be automatically selected from 0 to n. Automatically 0 to n means up to 7. Everything will be selected, everything. Okay, you are not going to give it. Now I need to, so rows are there already selected. Now let's work onto the column. So onto the column, 0th column, it is 0th column. So 0th index number I will best fit it. So it will be giving me entire data. Suppose I want to give here to with this particular column I want to select. So simply I will write it here, df.ilog, show me all the number of rows and show me 2th index. So I will be getting 2th column. So rows I had just given entire, all, and 2th number column. Now I want to make a selection. You think it, suppose in a 0th column, I want to select the data from 0 to 4. See, only this much data. 0 to 4, I want to select this much data. So 0 to 4 means the rows we have to select 0, 1, 2, 3, 4. That's all. 0 to 4 I have to capture. So I will be giving, show me the data from 0 to 4. I will not give. 4 not. I will be giving 5. Because start index is inclusive, end index is exclusive. This is inclusive. 5th is exclusive. Okay. So remember, start is inclusive, X is exclusive. So why I'm giving 5? Because when we start counting the index here, so that will be going up to n minus 1. So whatever n is there, so n minus 1 it will capture. So here it will be taking 0, 1, 2, 3, 4. That's all. It will not be going to 5. N minus 1 it is going. Okay. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 will be captured here. Okay. So that is there. Here we are using this indexing and slicing because in machine learning, I need to capture the data with certain rows and certain columns. So there I'm going to use all this operation. So it is very important to understand the log or ilog operations. ilog means index location. Index location is much, much better. This one is much easier here. Okay. So these are very important operations to understand how we can fetch out the data. Got the point? So here, again, I'm repeating few things. df.ilog operation, whenever I'm going to take it here. So here, you have to give into the first parameter, you have to give the rows and as well as the column. And inside the rows, you have to give the range of start index and end index. Into the column also, you have to give the range of start index and end index. But remember, the start index is inclusive and the end index is exclusive. That is not into the answer. Same here, start index is inclusive and end index is exclusive. So that's why I'm focusing. Suppose students here, let's see. I want to capture this one with this much data. Only this much data. This much. So 2, 3, 4, 5, 6. So how can I do that? So for this now, wait here. df.ilog operation, and inside the ilog operation, I have to give the data with rows I have to select, and with columns also I have to select. So rows is starting from 2. So rows, I have to make a range start index. So start index, I have to take it from 2. 2 is the starting index. End index is 6 now. So I cannot give here 6, I need to give 7, because here this index is exclusive. Only up to n-1 values will be captured. Into the columns here, I need to check out 1 only. That's all. So I will be giving here 1. My data will be captured. Suppose here, I want to take the values in this 2th column up to here. So here I will be giving df.ilog. Give me the data of the rows as well as the column. So data of the rows will be starting from, see here, this, what is this row? 1 to 6. So 1 to 6, so 1 to 7 I need to give. I cannot give 6 because here the counting starts from 1, 2, 3, 4, 5, 6. That's all. This is n. So up to n-1, the data will be captured. Up to 6, the data will be captured. And the indexing will go for column number 2. So column number 2 will be there. Exactly. Right. You are getting, you are understanding here. Sandra, that will be taking care. In future, you will be getting idea how to do this with a big data also. Just wait, please. I'm going as per the requirements here. So first of all, let's understand. You don't worry for that one, that there's a big data. Yeah, there could be 2 big data, but we'll be looking for that. Wait, okay. Just to think, suppose here, I want to take the data with, let's say up to this one. Let's say this one I want to capture. Or what I do, suppose here, I want to see these 2 columns. All the rows of these 2 columns. So how can I write it? Simply, I will be writing here df.ilog. I need to specify the rows as well as column. So here, because I'm taking all the rows, so here I'm taking all the rows, and into the column, I need to start the column ranges also. Start, end. So what I need to write here is 0. Starting will be 0. And ending will be 2. You know why? Because end index is exclusive. So here 0, 1. 0, 1. So 0, 1 will be there. So you will be getting 0, 1. 2 will never be involved. Last index will never be involved. Suppose you think it. Suppose here I want to capture the data from 0 to, sorry, 1 and 2. 1 and 2 only. So let me write it here. df.ilog index location. Here I need to capture the data with all the rows and the values in columns starting from 1 to 3. So 1 and 2 it will be taking. So this is last index. Okay. End index. So this is exclusive. This will never be counted. Now, the same thing, if I want to change, suppose here I want to capture the slicing of rows as well. Suppose I want to capture in the 0 and 1. In this case here, I want to capture the slices from 0 to 4 up to here. So here 0 to 4 now. So start from 0 and up to 5. In this way, the data will be here. And in this case, suppose here I need the data from 0 to 5 up to here I need it. So I will be just taking the data from 0 to, it is 5 now, 5. So I will be taking it to 6. In this way, I need to fetch out the data. So let me frame it out. Let me write it now. Let me keep on writing here. So it will be much more clear. But here I'm just making you understand a little bit here. Just wait, please. Let me write it few times. df.ilog. Just wait here. Give me all the rows and show me the 0th column. You can just start matching it with it. See here. This one is just showing here this particular 0th column and this one. This one is the entire I had captured. Okay. Now here, suppose I want to write here. Suppose I want to fetch this 2th number. Let me fetch out this this particular 2th number I want to fetch out. Okay, so what I can do here, simply I will write df dot I log, show me all the rows and 2th column. So here it will be giving you the 2th column. So you can see here, I'm having a 2th column here. Just wait. This one is a this one is a 2th column. This one is a 2th column. See, this one is also 2th column. In a similar way, suppose I want to fetch out the 3rd column. Students, if I want to fetch out the 3rd column, so what would be the command? 3rth column, 3rth column. Can you tell me what would be the command for 3rth column? Show me all the rows with 3. Thank you for your responses. Thank you. So 3rth column I would be having. Got the point here? So you can see the 3rth column and this 3rd column. You can see here this 3rd column, and here also you can see the 3rd column, it is there. Up to here it is okay. Okay, just wait, please wait. Up to a 3-4 commands, if you are able to understand, you can just raise hand. These 3-4 commands you are able to understand how I'm performing it with the iLock operation. 0, 2, and 3. Okay. Now let me take the DF again here so that I can see the data well. Now let's go ahead with the rows. Okay. Suppose here I say, I need the data up to here, see up to here. So how can I do that? Simply I will write df dot ilog. So student, I need 2 parameters, rows and columns. So into the rows, I have to give starting row 0, ending row 5. Starting row 0, ending row 5, because 5 is exclusive and the column number is 0. Just to check it out, the data, this one and this one, see the output. This one is clear to you? Line number 11 and 12 is clear to you? Okay, wait, let me tell you, why cannot I use lock operation? Lock operation is only used for, lock operation is only used for label based. In lock operation, I have to give the labeling just like A, B, C, D, E, F. I cannot use index there. Label based operation only understands A, B, C, D. It will not understand 0, 1, 2, 3. So for me, iLock operation is easy. Got the point here? Yes, the column labels must be present for lock operation. Yes. Yes. Okay. Now, suppose here, I want to capture this data. See which data? Wait. From 2 to 6, I want to capture. Students, can you think what would be the iLock operation? I'm giving you time. For lock operation, label giving is must. Means here we have to give a label in lock operation. But in iLock operation, no need to give only 0, 1, 2, 3. My index will work. Can you give me how should I write this command? This one, only this red block I need. Just wait here, 2 to 7. So you're saying 2 to 7 and give me 1. Right. Just wait here. Wait. Exactly right answer. Let me write it. Wait, please. So you are saying df dot ilog 2 to 7 and 1. Correct. Again, let me take it. Okay, right, it is right. Just wait, please wait. Just wait. In lock operation, just wait. Whenever I'm giving iLock operation, I'm using the index location operation. iloc operation needs to take index values. These index values must be present with the index location operation. Without it, iloc operation will not work. Second case, loc operation, label-based operation always need labeling, just like A, B, C, D. Then only I can perform the loc operation. I cannot use here 0, 1, 2, 3 index operation. So the major difference between loc and iloc is loc always take the label-based, as the loc means label-based, and iloc means index location-based. So here I can give 0, 1, 2, 3 indexes. Here I'm just working with the 0, 1, 2, 3 indexes. So for me, much favorable case is iloc. iloc is much better. It is easy and much better. Okay, so here I'm taking some more operation. Let me think, suppose here I want to take here the rows starting from 0 to 5 and up to these number of columns. Think it, try it, how to make this operation. I'm giving you time. Think it. For loc commands, we can give a labeling to the rows as well. Just wait here. Let me write here. Just wait. Rows here, 1, 2, 6. And I need to give a column now. So I have to give the range of the column. So range of the column will be, starting index will be 0. Ending index will be 3. Just to check it out, your operations. You know why? This will be there. 1, 2, 6, 0, 2, 3. See here. Why I'm giving here 0 to, why I'm giving this 0 to 3? Because here it is taking the data 0 to 3, means here it is 0, 1, 2. So 0 to 3 will be giving you 0, 1, 2. Oh, wait, here it will be giving 0, 1, 2, 0, 1, 2. 3 will not be coming into the answer. That is exclusive. Got here, I'm reading all these things. Okay, so I'd explain it even. Okay, so you can see here. Just wait here. Wait, students. Just wait, please. Here, wait. Suppose here. Give me a cut for this one. Think it. Think it. I'll give you a chance. What could be the possibility? Give me your answer, please. Okay, I'm getting some right answers. I'm getting some right answers. Okay. 0 to 7. Now here, just wait, let me tell a few things. Into the columns now, I have to start with 1. I have to leave this. I have to leave this end. Because if I give here 3, it will cut to 2. See here, wait. Just wait here. See here, it is taking 1, 2, 3. Here also it is taking 1, 2, 3. Here also it is taking 1, 2, 3. Because I just leave this end index blank, because automatically it will go from 1 to end automatically. If I give here 3 now, suppose here 3 is there, I am giving 3. So, cut will be from up to 2 only. 1, 2. So I should not give it. I should not give it. But what I can do, I can give a 4. Though I know that 4 is not present, but I can give it. But that is not a correct thing, I'll tell you. It is not a correct thing because there is no 4. So it is better now that I should leave it. I should leave it. This is the better option. Leave it. Is it okay? Okay. In this way. Okay. So up to here it is okay. Good. Up to here the things are clear to you, no? Huh? Things are clear now? Okay. So now let's see. Three, 2. I'm leaving from here. So it will take from 3 to end. And I'm giving 0 to 3. So here it is giving it is starting from 3 to end automatically, 3 to end, and it is taking 0 to 3. So 0, 1, 2. And this way. Okay, so in this way you can make it here. Just wait here, wait. Okay, see one more thing. See, if I'm writing here df dot ilog, and here into the rows here, I'm giving start from 0 to end. Automatically, it will take all the data from 0 to end. And into the column also, if I'm giving 0 to end, automatically it is taking from 0 to end. Okay. Automatically it is taking 0 to end. If I'm giving here df dot ilog, and in operation, I'm giving in this way also. Still, student, it will be giving end to end operation because I'm not limiting anything from 0 to end. Everything will be there. This way also and this way also. Okay, so by default, it is going to take it here. But if I'm writing here df.ilog, and here I'm just giving the data starting from 0, automatically 0 will be there. I'm taking the data with 7, and here also I'm just giving the data with 7. Okay, but here it is cutting 6, last one, 6, 6. Ah, here it is 3, 3, 3, 3, 3, 3. 3 I can give it here. in this way. So cut is there. Here the cut is there. Here the cut is present. Okay, so this one is overall about the indexing and slicing in positives. Slicing and indexing positives. Okay, so this is here. Up to here it is okay. You can just raise hand, that's all. Okay, fine. So in this way, you can do the slicing. They are very important. Whatever we are doing it here, they are very important. Okay, so now let's go ahead with the negative slicing. Suppose here I'm just taking the data frame. Inside the negative slicing, how the data goes. So the index will goes in a way like here it will be taking the data just like -1, -2, -3, -4. It is just a reverse. Here the data from we are taking from like our left hand towards the right hand, but here the data goes reverse from a right hand towards the left hand. It will be there. Okay, that is there. Please rewatch the video, Manish, here for this one. I had explained a lot and number of times I had to repeat the themes, please. Okay. Number of examples also I had given in front of you. So you can, it is better, you can repeat the video. Okay. Now see here, we are having the negative indexings also. Okay. So let's go ahead with the negative indexings. For the negative indexing, suppose here, this data is a -1, this one. Suppose I want to capture this one. So how can I do it? Simply I'll write in the df.ilog operation, and inside it, it's the same way, show me all the rows, but -1 column you have to show me. Okay. Now for 2, 1, if I want to capture this data entirely, so I have to write here df.ilog operation. And here I need to write -2. Students, can you tell me if I want to capture this particular column in negative indexing, what should I write the command? How to write a command if I want to capture this particular column in negative indexing? In negative slicing, how to capture it? So here we are capturing it with colon and -4, that I can do that. -4 I can give it here. So let's go and let's do it here because I just shown you -1, -2, -3, and -4 I have to give. So here simply I will be writing here df.ilog, and here I can give show me all the rows and give me -1. So -1 I'm having, you can see -1 it is just giving to you. Similar, if I need -2, so simply I need df.ilog, show me all the rows and give me -2. It is just giving me -2. Similarly, if you need to give df.ilog, and here you are giving colon and -3 as well. So here you will be capturing -3. Okay, so in this way you can do the indexing, negative indexing, so you can do. But here, how you would be doing negative slicing. So what happens now? Here, like -1, -2, -3, -4 you're giving. I want to see, let's say, all these two columns. Let's say this column I want to see, these two columns with negative indexing. So simply I will write in df.ilog, show me all the rows with -2, that's all, and I will not give any end. Because now what is happening here, this is a little bit different here. First, the pointer will go from, compiler will go from here to the side, means from right to left side, and from then again left to right side it will come after counting. So here it will say start, end, start, end. So here it is taking the data from -2, -1 automatically. It will not, you have not to specify here -1, because if you specify here -1, so it will be taking only one data, one column only. So let me try here. Let me do it here. Df dot, just wait here. -1 is the end index here. Df dot I log, and here I have to capture. Show me all the rows and show me the data of -2. That's all. I'm not writing here -1 because see, let me show you both of the things. Suppose here I'm just giving my -2 and that's nothing. I'm giving an end index. Can you see here 2 and 3 is coming 2, 3, 2, 3, 2, 3, 2, 3, 2, 3. I'm giving it here. But at the same time, suppose the same I'm just giving -1. So if I'm giving here -1, cut is there. What cut is there? Only single is there, no? You know what is happening? Only 2th it is giving. So what is happening here? -1, -2. So when I wrote it now, so only it is capturing -2. It is not taking -1. So only this point it is taking. Only this one it is taking. It is not taking -1. So if I need both, minus this, I need -1 and -2 both. So I should not give the last one here because I want to retain. So I will not give it. Instead, I will give it blank. So automatically it will be taking the data. End is excluded. Exactly. Okay. Now think it, suppose here I'm having the DF with me. And here I want to have the data from okay, just wait here. Let me think. Oh, okay. Let's say suppose I need this data, this one only this, both of the data and negative slicing. So what I'll do, df.ilog, and in ilog I will be giving, show me all the rows and this data. In columns I need to give -3 to, because the traveling of the pointer will be from here to here and from here to here again. So -3 to -1, because end is exclusive, so it will be counting -3 to -2 in this way. Okay. So here I need to write. Show me all the rows with the -3 to -2 that I need to give. -3 to -2. No, -1 I have to give. Now I'm getting. I'm getting this one. -1, -2, -3, -1. Up to here it is clear? You get understanding now that how the things are working in negative indexing as well. Okay, suppose here I'm writing here df dot. Thank you for your hand raising. Show me all the rows and show me the data from -4 to -1. So what you will be getting? -4, -3, -2. It is comma. It is comma. -4, -3, -2. 3 things you are getting. -1 will not be included. It is excluded. It is excluded. You cannot write -1 to -4. No, that is not recommended. -4 to -1 is wrong because these are negative indexings. Okay, so never write those things here. So like here I say, here dot, I will never recommend you to write in this way here. -4. Number of students, no, number of students do this way. That is a wrong. That is a wrong. That is an inconsistency. You will be getting in this way. This is never recommended. No to it. Okay, so in this way, suppose here I'm writing df dot I log. So here you're writing show me all the rows here and show me all the data from -4. So here it will, wait, oh, not in this way. So all the range, it will be giving you entire data. Automatically, it will be giving you entire data. Okay. No, wait. Here, see, you will never get like you need this data or you need this data. Means here, whenever we need an alternative, we cannot get it here. I need a range only. We can work on the range because the things are created in a way which we can use for the data science and machine learning, because here we need the range of the data, not alternative data. Even you cannot do it here. Okay, with range functions, na ranges, you cannot do that here. Yeah, if we need here, suppose here I need a -4 only, so here I can just give tf.ilog, show me all the rows here and -4. Oh wait, yeah, just wait. And -4. So automatically it will be taking -4 operation. All things are clear to you up to here? Can you do it on your own? You're quite confident. Can you do all these things on your own? Good. Thank you. Thank you. Thank you. So now here, just wait. Here I'd given a lot of operations the similar way. So you can write any of the things, that is up to you, that what you want to select. iLock operation, you can give any slicing, you can do any indexing, you can do. That is for you only. So whatever you want to do, you can do that. Okay. Okay, so can you do all of these operations easily now? Okay, thank you. Fine. Okay. So these are the cases of indexing and slicing. Okay, you must remember all. This is a very simple operation we need to remember. Now let's go ahead with the very small operation of pandas visualization. Inside the pandas visualization, we are having certain visualization method through which we can visualize the thing, such as we are having a bar method to plot a bars. We are having a histogram, box plot, or scatter plot. These are very basic functionalities for the visualization. So pandas is a very smaller library for the visualization purpose I'm having. So let's see how to do the pandas visualization. So you can see here, suppose here, I want to make certain bar plot here. Okay, so here I'm taking any data randomly. Any data here randomly I'm taking. So I'm taking one of the operation here, such as let me use here this operation also I can use. Wait, df rand function I can use. With the rand function I can take just wait, all the positive data. Positive random numbers could be generated. Positive random numbers could be generated here. It is rand instead of rand function. So rand function inside the numpy.random, we will be giving all the positive number here. So this one is the data frame here. So there is one of the method here for visualization. That is a bar method here. With the help of data frame.plot.bar, we can just plot all this data with a bar. Here it is just giving me certain bars. Visualizations here it is giving me for this data. It is any random data. So basically any bar it is giving me here. So what it is showing me here as let me write here. Oh, wait here. 6 rows. 3 columns. Let me delete it. 6 rows, 3 columns here I'm having. 6 rows, 3 columns here I'm having. So what this plot is doing actually, it is just taking all the values from this data, random data here. So here it is plotting. Suppose here you are having here in this table some values you can see here, like 0 to 6 rows. You are having the 3 columns you are having. Okay. So if I want to plot it, so 0 to 5, so 6 rows I'm having. So how this is plotting, let's say it is taking all the data from here. Suppose this one is a 0th number row. So these bar represent for the 0th number row. This one is the first number row, all the data. So this particular bar represent the first number row. This is the second number row. So all these data are represented with the second number row. Third row here, this data represent the third number of rows here. So basically, here it is taking like if I'm saying like 0, 1, 2. So here, whatever values for the, let's say, suppose I'm having a 0th number row. So this data is representing for the 0th number row. So here it is having the values of 0, 1, 2. So all the values, the 0 is represented by blue, 1 is represented by, means 0 column is represented by blue, 1 is represented by orange, and 2 is represented by green color. Suppose here the values for 0th column is 0.53. So for the 0th column, this blue color is representing the value of 0.53. For first column, 0.52. So this one is the first column for 0.52. And for the 2nd column, it is 0.89. So here it is representing 0.89, the green color. The similar, if you take row number 1, so all these values are represented here with 1. All these values are represented with 3 different data with 1. The similarly, if you are having a 5th number row, all these data are representing these different values. So basically inside the pandas, we are having only few visualization function which could be used. Okay, so this could be any random number I'm generating. I'm just trying to plot it here. In future, I will be taking the actual data, but here we are just learning. Okay, so next here, I can see, let's see the another one. Okay, suppose here, I want to see this data with in a different way. So how can I plot it? df.plot bar stacked is equal to true. This is, in this way you are getting the data one upon another. Here we are getting the three different bar I'm getting, but the same thing I'm getting with the one of the parameter inside plot.bar, that when the stacked is equal to true, so one upon another I'm getting the data. Okay. Suppose here I need the data in this way. You can see this is a horizontal way. So how you can get it? Simply you can write here data frame dot plot dot RH. H means horizontal. So here it is just going to represent all the data in horizontal. Okay. And if this data you want to represent as, means stacked data also you want to represent it in horizontal way. So here you need to add only one thing, stacked is equal to 2. It means show the data in this way, horizontal mode. Here I'm looking all the data in vertical mode. Here I'm taking all the data in horizontal mode. Just by giving small commands only, that's all. Now, okay, this one is a histogram. What is a histogram? Wait here, let me take data.plot.hist. Yeah, plot. Okay, so basically now what is histogram? Let me tell you. These are the default colors. Are there? There are certain parameters you need to check it out. I'll be telling you with another library, the changing of the colors also. Wait a minute, wait, please. Okay, so here now, suppose here I said, like, what is the histogram? Let us try to understand. Basically, now histogram gives us the count or frequency it gives you. Counting or frequency. Counting or frequency. So, actually, na, just wait here. When we talk about the histogram, histograms gives you frequency or count. Frequency, or you can say a count here. Suppose here you say, I'm having a data between 0 to 100. So I'm having a data. These are certain marks. Let me take out any marks. Randomly, I'm taking a marks here. Like 15, 20, 22, 30, 38, 44, 39, 48, 49, or here 43, 40, 45, it is 45, 50, 54, 56, 60, 61, and goes on number. The point is here, if I want to plot this data with a histogram, so how we can plot that? For that now, basically, I need to give here the intervals of the marks here. Suppose I'm starting from 0. So I want to plot the data that how many students receive the marks between 0 to 20, 20 to 40, 40 to 60, 60 to 80 in this way. And here also I'm side by side counting the frequency. Here I'm having the frequency. So here now suppose here I say like just wait, just wait. So here now, I need to check because here I had created a intervals. So these intervals could be created by the bins also. We said that bins are there. Bins, what are the intervals basically? So I'm just giving like 20 as a bins or 20 as an interval. So 20 gap I'm taking. Now I have to check that how many students had achieved the marks between 0 to 20. So only 15 and 20. So only 2 students have achieved the marks between 0 to 20. So here the frequency is there 1, 2, 3, 4, 5, 6, 7 goes on. So I will say only 2 students has achieved marks between 0 to 20. If I say how many students achieve marks between 20 to 30, no, it is 20 to 40. Na? So 20 to 40 up to here. So it means 1, 2, 3, 4. 4 students achieve marks between 20 to 40. So four students in this value. Suppose you think how many students achieve marks between 40 to 60. So 40 to 60. So all this 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So it means 8 student has achieved marks between 40 to 60. So basically what we are trying to achieve that what is the count, what is the frequency of the provided data. Okay, what is the count? What is the frequency of the provided data? So what is this basically here? Histogram gives you the frequency of the data, right? So here the same we are doing it here. See, here it is taking df.plot.hist. Why it is giving this graph here? Because currently it is taking all the data from these random numbers. The random numbers are not exact integer values, they are decimal values. So because the decimal values are coming, that's why I'm getting this type of graph. But in because certain float data are there, when I'm going to take exact data, just like I'm taking a mark sheet, any average numbers I'm taking. So there, when I'm plotting this histogram, that will be coming with a very good views here. Because here, because I'm taking all the data with the random numbers, very small numbers are there. So that's why the number it is giving here output in this way here. Yeah, of course, it is giving a range of frequency distribution. Exactly, correct. Okay, now let's see what is a box plot. We can have the box plot feature like this one. Like this one I'm having. These are the boxes. So let's understand what are these boxes. So for here now, I can just write here, just wait here. There is a df.plot.box command is there. Data frame dot plot dot box command is there. Wait, box. It will be giving you box-like structure. Say her boxes are there. What does boxes gives you? Boxes exactly gives you some major information, statistical information. But because here you're not aware with any of these terms, so here let me tell you in a very simple way. In future, I'll be explaining in detail. It is giving you maximum minimum value. So here it is giving you the minimum value. Here it is giving you the maximum value, maximum value. Suppose here this value it is giving. So here it is saying in 0th column, this is the minimum value, and in 0th column, this one is the maximum value. So if you go and check it out the data, wait, because I had already created a data above now. So let me take the data here. Suppose I'm writing here DF. So here it is giving me this DF. So let me take this box plot as per this data frame here. Now I can see this one. Here it is saying, I'm saying that this box plot gives you this is the minimum value and this one is the maximum value. So in 0th column, you can see minimum and maximum value. So let me check it out from here. Suppose this one, where is the 0th column? In 0th column, maximum value is 0.99. Maximum is 0.99 and minimum value is 0.03. Minimum value is 0.03. Okay, so let me check it out from here. Okay, so you can see here 0.99. Here it is a maximum value 0.99 and here it is a minimum value 0.03. Okay, the same here if you check it out in column number 1. This one is the minimum value and this one is the maximum value. The same if you check it out from here, you can just check it out on your own whenever you are working. Oh, just wait here. Just wait. So here you can just check it out. What is the minimum value and what is the maximum value? So minimum, maximum value it is given to you. Though boxplot give you certain more information also. In future, I'll be telling you because here in future when I'm explaining more things now, so you will be clear that what boxplot gives you. Okay, so there I'll be explaining. But as a starter here, you can just understand, yeah, we are having certain visualization into the data science environment. More you'll be learning slowly. Okay, this one is a box plot, and let's go ahead with the scatter plot. Inside the scatter plot here, we are having a scattering data. You can see how the dots are coming. These scattering data are coming just with the coordinates, X and Y coordinates here. So okay, what it is doing here, here it is just generating one column here. Just wait. Let me do it here. It is much better. I'm generating here a data frame with suppose 50 rows and 4 columns, or I can say it here as a 25 rows or 4 columns, and the 4 column names are A, B, C, D, because I need the names A, B, C, D. Then here, it is not scattered. I need to suppose that this one is a data frame. It could be any students, does not matter. It could be any value, does not matter. Even if I'm giving it here up to 20 also, it will be working for you. 20 rows, it could be any, does not matter. Don't worry about the data. Okay. Now, if I want to write here, scatter plot here, so simply I will be writing here. PF dot plot dot SCATTER, scatter. So in scatter now, I need 2 inputs, X and Y, because in scatter plot, I need to make the coordinates of X and Y. So here in X, I need a column value. In Y, I need a column value. So here it is the A or B, I can give it here. So it's like A. A. Student, it does not matter that what are the coordinates coming, but actually it is taking the X and Y coordinates. But here, let it make any data. Suppose here you are giving a column number here, C and D. C and D also you can give it. So here you can give C and here you can give D. That is your choice, doesn't, but only 2 columns you can give it. It could be O, O, O. It could be any. Again, mistake here, syntax error. Some mistake is I'm doing. Quote problems are there. Comma. Y is equal to quote D, quote this one. Now it is okay. It could be any data. If I'm making a change, suppose here I'm writing here, it could be 40 rows with 4 columns. 40 rows with 4 columns. So it is generating more data. Let it be generated 40 rows. So here you will be having much more density data you are. The point is there that you should know that these 4 to 5 visualizations are present. Okay, and you should be aware that yeah, we are having certain visualization in the world of pandas as well. Is it okay? Up to here it is okay now, you tell me. So you can make the visualization on your own. You can take any random data, does not matter, because initially you are taking random values only. Because these are just a starting, I'm doing that. Okay. Yeah, we can use all these things in real-time scenarios also. Yeah, we can do that. But here I'm just taking a random data. I will be taking certain more data slowly because I'm starting it only. So these are very interesting. We can do that easily. Okay. All these things we can do it very easily. Okay. Now let's go ahead with certain. There are a lot of operations here. Okay, let me frame one index changes here. Suppose here I'm taking a data quickly here. I'm taking this data. Okay. Here. Suppose this one is one of the data. So let's see what are the DF is there. Here I just created a dictionary and I'm passing this dictionary inside the data frame. The dictionary says the day, visitors, and the bounce rate is the keys. And rest these values are basically values. These are the values. Okay, this is there. But the point is there's one thing here. Suppose students, right now, what is happening now? Right now, index is 0, 1, 2, 3. By default, the index is 0, 1, 2. I want to cut this index. I want to make this day as the index. How can I do that? There is a set index method inside the data frame. So what I can do, df dot, there is a set index method. I'm going to use the set index method and I can say kindly make kindly make this day as the index. So you can see here this is cut and now the day is the set index. So set index is a method where you can see your day as the index. Okay, so this is there. Right? Now there is one thing, students, see. If I'm looking here, DF again, just wait. Still, you will be getting the index here, 0, 1, 2, 3 you're getting, and day also you're getting. But you will say, ma'am, already you have set a set index. So how this 0, 1, 2, 3 is appear here? Already you had created day as the index, but why it is giving here into the DF? Because it had not saved it. For this, what you have to do, if you want to save it, so what you have to do, you have to save it. Like here, I can say, you have to save it just like into the another data frame. Let me tell you df1. So once I had saved it now, so now I can see df1 is having day as the index. Okay, df1 is having the new value day as the index, but suppose you want to see what is happening to the df. DF is still having the original data, 0, 1, 2, 3 as an index and day also. So what has happened? If you say, ma'am, can we change the DF permanently with index as a day? Yes. How? For that, now there is one of the parameter in place is equal to true. There is one of the parameter in place. So if I write that in place is equal to true, my DF will be saving the data permanently. Got the point? Means here, if I'm writing, see here, if I'm writing here df dot set index, and here I'm saying day, so now this will not take permanent changes. I need to save the data in df1. So df1 will be holding the permanent changes, but this will not take. So the point is when this df will be taking the permanent changes of setting out day, because if you're looking here, still it is saying this is a default index, then day is there. So there's no change. For this, if I want to make the changes, what I have to do, I have to add one more here. In place parameter. In place is equal to true. If I'm giving in place is equal to true, so the changes will be occur in place of data frame. How can I do that? For this, you can see what I need to write. I'm saying to make the changes, then also you give. Okay. See, now it is taking the permanent changes. Now it is taking the permanent changes here. This is cut. So this will be there. So now it is there. In place is equal to true. This one is giving you the permanent changes. So in place is equal to true is a parameter which will be giving you the permanent changes. We should not give df is equal to df dot set. No, that is not recommended. This is recommended. That is not a right way. df is equal to df dot set index. That is the wrong way. You should not do that, because here you need to give here better way. You need to set out in place is equal to true. Okay. Do not reference the df1 again. That's not a best practice. Do not reference df is equal to def. So it is better. If you want to do that, now it is better you can give in this way. Another data frame you can give it. But here now, it is better to give df dot set index, means whatever functionality we are using, in place is equal to true will help you to make the changes into the original data frame. That is the best practices. Okay, so in this way, basically, we can change the index in pandas finally. Now, second, if I want to make the change to the visitors, because what is happening here, right now, the name of the column is visitors. In the same time, if I want to use it as another name, how can I give it? Simply, I will write this command df.rename column is equal to visitors to user. So what I can do, it means my visitor name of the column is changed to the newer name as a user. So here I'm changing the names also. Okay, fine. Now let's see data analysis in Python. So we can do a data analysis in Python. Suppose this one is the data I'm having, random data here I'm having. This one is the data I'm having. It could be any data. Now there are certain methods inside the Python which can be used for the data analysis purpose. So basically there are few methods such as, very interesting methods are there, such as data frame head method, which will be giving you top 5 rows, data frame dot tail method, which is giving you bottom 5 rows, sample method, which is giving you any one row. But if you want to see 3 top rows, you can just pass on the parameter as a 3. Top 3 rows will be displayed, bottom 3 rows will be displayed, any 2 samples will be displayed. So here I can use all these commands. So here I'm just writing df dot head operation. Head will give you top 5 rows. So here it is going to give you top 5 rows. Okay. If I'm writing here df dot tail, so here it is giving you bottom 5 rows, df dot sample, bottom 5 rows, bottom 5 rows means here it is giving you, wait, it is going to give you bottom 5 rows. Head will give you top 5 rows. Sample will give you any row. It could be giving you any row. So sample, if I'm writing it here, so it will be giving you any row. df dot head 3 rows. So top 3 rows it will be giving. df dot tail, it will be giving you any 3 bottom rows. df dot sample, it will be giving you any 2 sample. It could be any 2 sample. So basically, head It could be any data you can take. Head, tail, sample, head 3, tail 3, or sample 2, anything you can give. These are basically Pandas data analysis. So here we do use data analysis Python in very easy way. I'm just doing it in very easy way, very convenient and easy way here I'm using. So this is overall. So that's all for today. Thank you very much. Thank you. Thank you.